Let's work out number 54. A 16-foot pole. Okay, so I'm going to go ahead and draw the pole. So here is our 16-foot pole. It's supported by two wires that extend from the top of the pole to points that are each 8 feet from the base of the pole. Okay, so there's two wires, and they extend from the top of the pole to points that are each 8 feet from the base. So it extends from the top to some point over here, and this distance here is 8. And the same thing has to happen over here because there's two wires. And this distance here is also 8. Then it says, find the total length of the two wires. Leave answer in simplified radical form. I should say leave the answer. It looks like it's a typo. So leave the answer in simplified radical form. So here, that's our right angle, and we'll call this C. So we can use the Pythagorean theorem to find C. Once we find C, we can do C plus C to get the total length, right? Because we only have to find it once. Okay, so C squared, that's the hypotenuse squared, is equal to 16 squared plus 8 squared. That's the theorem of Pythagoras. It says if you square the hypotenuse, you can add up the squares of the sides. So this is C squared equals 16 squared is 256, and 8 squared is 64. So this is C squared equals, let's see, 4 plus 256 is 260. 260 plus 60, 320. 320. Then we take the square root of both sides. So we get C equals, well, we're supposed to get a plus or minus, but C is the length of a wire, so it's just going to be the plus. So square root 320. And the largest factor of 320 that when we take the square root we get a whole number, I believe is 64. Because 64 times 5, see, 5 times 4 is 20, carry the 2, 5 times 6, yeah. So 320. So this is going to be square root of 64, square root of 5. Right, square root of 64, square root of 5. So C is going to be 8 square root of 5. But we want both wires, right? So that would be 8 square root of 5 plus 8 square root of 5. So that's going to be 16 square root of 5. And the units in this case looks like it's feet. That's it.